Hi. Alright, in this video we're going to discuss about the volume of the solid form by revolving the region bounded by the graph of two curves, right? It's between two curves about the x-axis, alright? So in these cases here, it's between these two curves, means that the region bounded by these two curves is rotated about, revolving about the x-axis, alright? Of course, at first we should sketch the graph so that we can see what square root of x, right? Square root of x. So the graph will be looked like this way, right? And y equals to x squared. So the graph, okay, this will be the graph for, okay, I just put this as y1, y1 square root of x, and the graph of y2, okay, I put this as y2, so which is equals to x to the power of 2, so 0. And this is the region bounded, right? This is the region bounded between the graph of y1 and y2, all right? So, and this region is going to rotate about the x-axis here, all right? Rotate about the x-axis here. So means that there is a outer radius here. You see, this one is far from the axis of rotation compared to this one. Of course, this curve will form a bigger solid, all right? It will form a bigger solid, which is the graph of y equals square root of x, will forming a bigger solid, right? For this graph here. So this will be the graph of y1 equals to square root of x, right? Followed by this curve, right? This curve will form a smaller, but here is an empty solid here, right? Empty, right? There are no solid here. So means that we're going to minus this region, the volume form will be, I take the bigger solid by rotating this curve, take away, subtract away the solid formed by this curve, which will be this shape, right? Which will be this shape. This is the graph of y equals to x squared, and this is the graph of y equals to square root of x. So as you minus this solid, you will get the solid formed by this region here. Alright, I hope you have an idea of the solid formed by this region. So means that after I minus this, I will get empty, right? This solid have an empty solid inside here. So means that you will get the radius, which is the bigger radius, which is come from the graph of y square root of x, right? Square root of x minus away the graph for x squared, right? X squared. So the idea here will be the volume. Okay, I'm going to show you how to define the volume for this case. All right. Okay, let's define the volume generated by this region. So it will be a pi integrate from, all right, you have to know what is the intersection point here, right? So I have to equate y1 to y2, means that x squared equals to square root of x, right? X squared equals to square root of x. So I square both sides and I will have x to the power 4 and here to be x, right? So x power 4 minus with x equate to 0, and I factor out the x, I have x cubed minus 1 to be 0, right? So if I solve, I have x to be 0 and x cubed to be 1. So x is 1, right? X cubed is 1 when x is 1. So it means that it's between 0 and 1, right? This region. So it's integrate from 0 up to 1. And for the outer radius, about volume, we talk about outer radius, okay? This curve. This curve is far away from the axis of rotation, right? So we take square root of x, we take the y1 square minus away the y2 square dx, all right? For this case will be dx, because we rotate about the x-axis. So it means y1 square minus the y2 square. So, right, pi from 0 to 1, y1 will be square root of x to the power of 2, y2 x square, right? x square and square again. So then we integrating this one, then we will get the volume that we want. So this will become x, right? Square and minus with x power 4 dx. So now we're going to integrate this. So we have x to the power of 2 over 2, x power of 2 over 2, minus with x power 5 over 5, from 0 up to 1, pi, right? So then we have pi 1 square 1 over 2 minus with 1 over 5 minus with 0. So let's calculate. So we have 5 minus with 2. 5 minus with 2, we have 3 over 10 pi unit cube. For this case here, the volume generated